In this video, I'm going to explain what you need to know about the Hadron family of particles. The Hadron family can be divided into two. We have the baryons and we have the mesons. None of the particles in the Hadron family are fundamental. They all have an internal structure. That means they're made of other particles inside. In fact, these particles are called quarks. The baryons baryons always have the same composition. They're always made from 3 quarks, or if they're an antiparticle, they're made from 3 antiquarks. The only two that you need to know about are the proton and the neutron. All the real-world particles, such as the proton and the neutron, are made from up quarks and down quarks, which are here on the back of your data sheet. Even if you don't know the structure of these in the exam, you should be able to deduce it fairly easily from your knowledge of these particles and the information on the data sheet, and the fact that we need to combine 3 quarks. A proton must be made out of an up quark, an and a down quark, because from the sheet we can see this is charged plus 2/3, plus 2/3, and minus 1/3. If we combine all those charges together, you can see that comes to plus 1. A neutron, on the other hand, neutral, no charge, is an up quark and 2 down quarks. We look at Y, we've got plus 2/3 charge from the data sheet, minus 1/3, minus 1/3. That comes to a total charge of 0. We need to know a little bit more about the meson family, so I'll just go through that now. And we need to know the composition of 2 groups of mesons. But the rule is for mesons is they are always made from a quark and an antiquark. So always a quark and an antiquark. The first family that we're going to look at is the pylons, represented by that familiar pi symbol. The thing to remember about pylons, to use in conjunction with the information on the data sheet, is that pylons don't contain any strange quarks. In this course, the only 3 quarks you need to know about are the up, the down, and the strange. So no strange particles on this. By combining a quark and an antiquark, there are only 4 ways to put those together. We can have an up quark and an anti-down quark. Remember, this has charge plus 2/3. Because this is an antiquark, it has charge plus 1/3. So that gives us a positive pylon. Its antiparticle, if we swap over which one is the antiparticle, minus 2/3 charge and minus charge, we have a negative pylon. There are 2 ways of making a neutral pylon, and that's either by using a down and an anti-down, or an up and an anti-up. Both of these particles are incredibly short-lived, because as we've seen from our work on annihilation, they would simply annihilate themselves. And that's the whole pylon family, simply from a little bit of background knowledge in the data sheet. The other family of mesons that you need to know about is the kaons. The kaons are different because they contain a strange quark. Always one strange quark or an anti-strange quark, in combination with an up or a down quark. So again, if we just cycle through the various combinations, we can have an up quark in conjunction with an anti-strange quark. An anti-strange quark has a charge of minus 1/3. So a strange quark has a charge of minus 1/3. So an anti-strange quark has a charge of plus 1/3. This has got a charge of plus 2/3. So that gives us the positive kaon. Its antiparticle is the negative kaon. And there are two ways of making a neutral kaon. We can have a down and an anti-strange, and we can have a strange and an anti-down. One of these particles we need to declare as an antiparticle, and the other is the real world particle, which is difficult because each contains one particle and one antiparticle. And the thing to remember is it's the real world ordinary matter that carries the day. So the one with the anti-down quark is the anti-neutral kaon. And that's the structure of all the baryons that you need to know. I hope you find that useful. Thank you.